Imagine discovering that your DNA contains traces of a tribe that went extinct millennia ago. In this video, we explore how the genetic material of ancient and long-gone peoples from Europe is present in current populations. Join us on this fascinating journey through time and genetics, revealing new perspectives on Europe's complex heritage. The Picts, inhabitants of ancient Scotland between the 3rd and 9th centuries AD, dominated the Highlands and eastern regions, resisting Roman and Viking invasions. Their unique culture, marked by elaborate carved stones and a matrilineal society, thrived for centuries before their disappearance. The scarcity of written records about the Picts makes studying their history challenging. The few surviving records are mostly lists of kings and inscriptions on stones, many of which remain undeciphered. This lack of written information has posed a significant challenge for historians. Theories about the origin of the Picts include descent from the ancient Bronze Age populations of Scotland, migration from mainland Europe, or a mixture of both. As for their disappearance, hypotheses range from gradual assimilation by the Scots to conflicts with the Vikings or climate change. Recently, DNA analyses of Pictish remains have begun to reveal new information. A 2018 study in Lundin Links, Fife, showed significant genetic continuity between the Picts and modern populations of the Scottish Highlands and Islands, suggesting that the Picts may have gradually merged with other groups. These genetic findings are reshaping our understanding of the Picts and their lasting impact. As more DNA samples are analyzed, scientists hope to uncover other aspects, such as migration patterns, relationships with other European tribes, and insights into their diet and lifestyle. The genetic study of the Picts is just the beginning of a broader exploration of European genetic history. Other ancient tribes, such as the Cimbri, are waiting to have their genetic histories revealed, contributing to our understanding of the genetic landscape of modern Europe. The Cimbri, a Germanic tribe originating from the region that today corresponds to Denmark and northern Germany, emerged in the late 2nd century BC and began an epic journey through Europe. Their migration, which spanned from the Baltic Sea to the plains of Italy, shaped the European DNA landscape in ways we are only beginning to understand. Genetic tracking of the Cimbri presents significant challenges due to the scarcity of written records and the tribe's nomadic nature. Scientists combine archaeology, history, and advanced genetics to unravel this scientific puzzle. The Cimbri's journey was marked by notable confrontations, such as the Battle of Arausio in 105 BC, where, alongside the Teutons, they dealt a devastating defeat to the Roman forces. This event not only shook Rome's military power, but also marked the beginning of complex genetic interactions with local populations. Archaeological evidence, such as weapons and metal tools found in Cimbrian settlements, suggests a warrior society that was highly mobile. These artifacts, combined with modern DNA analysis, help scientists trace the Cimbri's migratory routes and identify regions of significant genetic impact. Recent genetic analyses reveal that the Cimbri share markers with other Germanic populations, indicating substantial mixing along their migratory paths. This intermingling created a complex genetic legacy that challenges simplistic notions of European ancestry. Studies suggest that genetic traces associated with the Cimbri can be found in modern populations in regions as diverse as northern Italy and parts of Scandinavia. These discoveries indicate that, despite their apparent disappearance in history, the Cimbri left a lasting genetic mark on the European continent. The genetic impact of the Cimbri on modern Europe remains a topic of intense research. Scientists are seeking unexpected connections between the Cimbri and contemporary populations, with the potential to revolutionize our understanding of European genetic composition and reveal ancestral links that transcend modern national and ethnic borders. The genetic impact of the Vikings on Europe was deeper and more enduring than initially believed. During the Viking Age, from 793 to 1066 AD, the Norse left an indelible mark on the European continent, not only as raiders, but also as traders and settlers. Recent studies reveal a surprising genetic diversity among the Vikings, challenging the stereotypical image of tall, blonde, blue-eyed warriors. Ancient DNA analyses show significant differences between Danes, Norwegians, and Swedes, indicating that the Vikings were not a genetically homogeneous group. In England, the Viking genetic impact was particularly notable. Approximately 6% of the English population's DNA is of Viking origin, with higher percentages in the north and east of the country. This pattern reflects the historical Viking settlements on the island. Identifying Viking ancestry in modern DNA has become a fascinating field of research. Scientists use specific genetic markers to trace lineages that date back to the Vikings, revealing surprising connections between modern populations and their Norse ancestors. A 2018 study highlighted that the introduction of ancestry from the steppes, including Viking genes, was associated with a significant genetic shift in the British genetic pool. This discovery revolutionizes our understanding of the lasting impact of Viking migrations, suggesting a replacement of approximately 90% of the existing genetic composition in just a few centuries. The genetic legacy of the Vikings extends far beyond the regions traditionally associated with them, covering much of Europe. This heritage is a living testament to a period of great change and cultural interactions, reflecting the complex and interconnected nature of Europe's genetic history. The Norman conquest of 1066, led by William the Conqueror, marked a turning point in British history, introducing profound cultural changes to England. However, recent genetic studies reveal that the impact of the Normans on the English genetic pool was less significant than their cultural influence would suggest. The Normans, descendants of Vikings settled in northern France, transformed the language, legal system, and social structure of England. The English language incorporated thousands of French words, and a new Norman aristocracy took control of land and government. However, the analysis of modern population DNA shows a surprising disconnect between this cultural dominance and the genetic legacy. Genetic research indicates that the Norman contribution to the English genome was modest compared to earlier migrations, such as those of the Anglo-Saxons and Vikings. Some regions, particularly in the south and east of England, where Norman settlement was more intense, show a slightly higher presence of genetic markers associated with the Normans. However, even in these areas, the Norman genetic influence is relatively limited. This discrepancy between cultural impact and genetic legacy can be explained by the fact that the Normans, although politically dominant, were numerically inferior to the existing Anglo-Saxon population. Additionally, the social practices of the time may have restricted genetic mixing between the Norman elites and the general population. The Norman genetic heritage is just one of many layers that make up the rich genetic mosaic of the British Isles. This discovery challenges our perceptions of conquest and heritage, highlighting the complexity of human genetic history. The deep cultural influence of the Normans contrasts with their subtle genetic impact, offering new perspectives on how we interpret the history and identity of European populations. This analysis of the Norman conquest serves as a reminder that each wave of settlement and conquest in European history left its unique mark on the continent's genetic landscape. Modern science continues to unravel this complex mosaic, revealing that cultural influence and genetic impact do not always go hand in hand in the formation of populations. The genetic diversity of the Celtic tribes is a fascinating mosaic that challenges our traditional conceptions of tribal identity in ancient Europe. The Celts, originating from Central Europe, expanded across the continent between 1200 BC and 500 BC, carrying with them a unique set of genetic markers that today help us trace their journey. Recent DNA studies reveal that the genetic diversity among different Celtic groups is significant, challenging the idea of a uniform Celtic genetic identity. Genetic markers associated with the Celts, such as haplogroup R1b, are common in Western Europe, but their presence varies considerably between regions, reflecting complex patterns of migration and mixing with local populations. Ireland, often considered a bastion of Celtic culture, presents modern DNA that is a blend of Celtic, pre-Celtic, and even Viking influences. This genetic mix illustrates how cultural identities can persist even when the genetic landscape is diverse and dynamic. Archaeogenetics is redefining our understanding of the expansion and interaction of Celtic tribes. Evidence suggests that the arrival of the Celts in many regions was a gradual process of cultural diffusion and genetic integration, rather than an invasion that completely replaced the existing populations. One of the most surprising insights is that the Celtic genetic heritage is a combination of influences from several waves of migration, including contributions from ancient Anatolian farmers and steppe invaders. This complex genetic mix highlights the interconnected nature of human history and challenges preconceived notions of ethnic purity. The Celtic heritage is an integral part of the rich genetic tapestry that defines contemporary Europe. This understanding leads us to question how other ancient cultures and migrations contributed to the genetic diversity we observe today, paving the way for new explorations in the field of population genetics and our understanding of European history.